Yes, sure.
نحن على الباوربوينت انه
Yes.
عملنا انه لاجرانج انتربوليشن وبس نعملها انتجرال ودغري بيطلع لنا سيمبسون. لا عم نعمل كل هذا.
اوكي. لانه نحن وقتها قلنا الميثود صح، بس ما عملنا لا، يعني ما ثبتناها صح او لا. قلنا we integrate and we get these coefficients صح.
إيه
بس
بدنا
actually
زيادة عن هيك
نعم.
بالفحص.
ايه بس actually انا
يعني
اذا
فكرة
اذا
بالفحص،
انت،
يعني أنا كنت
اذا قالوا
مفكر.
لك derive، اذا قالوا لك derive، اذا انت منك حافظ انه هي 1 over 3 ما بعرف شو، كيف بتجيب الكويفيشنتس؟ مش you want to get the result، كيف وصلنا
هيك
لهيدا الريزلت؟ اوكي. Actually وصلنا له in this way. This is a first method. A second method كمان هي انه تنطلق من من هيدي الفورم تبع نيوتن، اوكي، وتطلع الكويفيشنتس. يعني اثنينهم صح. اوكي.
هاي يعني ما لها حق اقول لك انه مناول انتجرال ودغري بيطلع لنا ال 1 over 3. لازم اعمل لك
ايه
اياها
لانه
سيستم.
اذا طلبوا منك to derive you should do this. You should put the steps. هلا اذا بدك تعمل نيوتن بالديريفيشن بيصير بدك تجيب انه بدك تعمل انتجرال لهيدا الترم، يعني لكل ترم هو اللي بيعطيك الكويفيشنت. يعني you can do it كمان بهيديك الميثود، انه بتقول if I integrate this term I get this coefficient. بس هون عم تثبتها actually، عم تعطي السيستم directly، يعني كيف عم نجيب الكويفيشنت. يعني هون كتبناها دغري A0 plus A1x plus A2x square. بالنيوتن اوكي الفرق انه just كتبناها in a different form. اوكي. ما اصلا نحن قلنا انه بالفيتنج وقت اخذنا اللاجرانجيان والنيوتن ابروتش وخدنا اول شيء البولينوميال ابروتش صح. انت you can do this or you can say انا بدي اكتبها، بدي اكتب بما انه it's second degree، يعني the second way كانت انه نعملها هيك. يعني you can put it equal to x minus، هاي الفانكشن فينا نكتبها let's say x minus x1 times. يلا قولوا لي انتم كيف اذا بدكم تعملوها نيوتونيان فورم كيف تكتبوها؟ مش انتم بدكم تكتبوا شي تايمز اف اكس 0 plus something times اف اكس 2.
هاي لاجرانج صح،
اه
مش نيوتن.
سوري لاجرانج قصدي. اوكي. شو بيكون ساعتها
Yes.
الكويفيشنت هون؟ what should we multiply by؟
x1 minus x2.
هي what is the idea؟ the idea انه هي لازم تكون equal for x equal to x0، لازم تكون equal to f x0 صح؟ يعني بده يكون
يعني
عندنا
لازم
هون x minus x1 times شو x minus
x2
x2
over
over
x1 minus x2
x0 minus x1
قد x0
times.
x0 minus x2.
اوكي وشو بعد ناقص؟ يعني بدنا نزيد كمان plus a term times what؟ times x1 صح؟ يعني we should add
Yes.
also شو حيكون الترم multiplying fx2؟ term multiplying fx2 حيكون x minus x0 times x minus x1 over x2 minus x0 times x2 minus x1 plus term multiplying fx1 اوكي يلي هو x minus x0 times x minus x2 over x1 minus x0 times x1 minus x2. اوكي فيكم تعملوا هالميثود كمان to prove ال 3 over 8. اوكي يعني كيف بيجوا الكويفيشنت؟ x1 minus x2. So you can say that fx0 to determine نحن بالانتجرال اوكي مفروض الانتجرال بالسيمبسونز 1 over 3 مفروض يطلع a certain coefficient حنسميه اذا بدكم c لازم يكون عندي c times fx0 plus d times fx1 plus
دكتور I don't
نعم
think حيلا شيء من اللي عم ينكتب عم ببين عنا.
you are not saying
No, عنا screen is frozen.
okay يلا I will let me check. Do you see now what is written?
Yes.
Okay, great. Okay, so if we want to do the derivation using Lagrangian form, okay, so we write the integral will be a coefficient c times fx0 plus a coefficient d times fx1 plus a coefficient e times fx2. Okay, so to determine what are the coefficients c, d, and e, all we have to say is that by comparison, if I integrate this, okay, then c should be equal to integral of what? Fx0 is a constant. It's f at x0. I can take it outside of the integral. So c, by comparison, is the integral between x0 and x2 of x minus x1 times x minus x2 over x0 minus x1 times x0 minus x1. Sorry, x0 minus x2. Okay, so this will be c. And the coefficient d is integral from x0 to x2 of this function. Okay, and e is integral from x0 to x2 of this function. So this is another way to derive Simpson's 1 over 3. Okay, but the calculation is really a little bit it's challenging and it's a little bit long, but this is the method. Okay, and if I just ask you for the system or to how to find the coefficients, this is a first method and this is a second one. So if you want to go with the first approach, you define f2 as a0 plus a1 plus a2. You should write a system of 3 equations, 3 unknown. If you want to go to the Lagrangian technique and you define your function in the Lagrangian way, then you can define c, d, e based on these integrals. Okay? And this is what I care for. I care for that you know how to find these coefficients. I will not ask for lengthy computations. And what I care, for example, if you use this, if you started from here, I just want you to write this system, because the solution is a little bit difficult, okay? But it's just a system. But because you don't have numbers, it will be a little bit difficult. So you can get a0, a1, a2 just by substitution. You can solve, and you get this complex issue. And when you substitute in the expression of the integral, okay, and now you know that you are computing your integral by integral from a to b of a0 plus a1x plus a2x squared. If you do this, you get, it's really simple. The integral is a0x plus a1x squared over 2 plus a2x cubed over 3. But what is complex is the expression of a0, a1, a2. And the expression of a0, a1, a2, you can get it from solving this system. And here you have the complete solution. Okay, don't worry, I will not ask you for this, but this is how we do it. Okay, you get a0, a1, a2 after solving the system. But if you have numbers, for example, if I give you numbers, I can ask for derivation using numbers. It will be much easier for you. And this will be really, really simple. It's a system of 3 equations, 3 unknown. You get a0, a1, a2. And then when you integrate, okay, you can come up with the general Simpson's 1 over third rule. Because when you integrate and you replace a0, a1, a2 by their values, you will get that the general form is b minus a over 6 times fa plus 4f of a plus b over 2 plus f of b. Okay, and we know that b minus a can be replaced by 2h, and this is why we get that the 1 over 3 coefficient. So it's h over 3 times this term that you know already. So the coefficient of the extreme points is 1, and for the middle one, it's 4. Okay. Any question on this?
دكتور ال coefficients A0 A1 A2 بيطلعوا مظبوطين حتى لو السيستم الكونديشن.
لا، ما انا هلا you can use your calculator to get that. اوكي، هون ما عم نحكي بقى يعني فيك تحلهم بحيلا تكنيك. هلا اكيد اذا بدك تحلهم بالنيوميريكال تكنيك فيها ماتريكس، والماتريكس الكونديشن ما بيطلع على الارض، بس اذا عم تستعمل let's say your calculator you will not get an issue, especially انه you have a high number of digits that you can store. Okay.
Okay, yes.
Okay, so now if here I ask you to derive the composite Simpson's one-third rule, so it's very simple. You can do a small scheme. Okay, now I have, let's say, 3 points, 3 nodes. So coefficients here are 1, 4, 1. If I want to use the composite method, this node will be common with another interval. So I can do this figure now. So this point that is common, then we should add the coefficients, and here we'll get 1 plus 1, which will give us 2. Okay, now this point will not be affected, it's in between, so it will be 4. Now this point will be common with another interval, so we'll do 1 plus 1. This is why in the composite method, in the composite one-third rule, what will be the coefficients? 1, 4, 2, 4, 2, okay, etc. until the end point should be 1. Okay, and at the end we have 2, 4, 1, the extreme point. Any question on this problem?
دكتور
Yes.
أنا بالأول كيف عرفت إنه هي quadratic equation؟
هي quadratic لأنه Simpson's one-third rule كم تستعمل point؟ أنت when you take your segment, how many points you use? 3. Okay, if you are using 3 points, what is the order of your polynomial fitting?
2.
Yes, because when you use 2 points, then it's linear. When you use 3 points, it's second degree. But 3 over 8, you use 4 points, so it's to the power 3.
Okay, thank you.
Okay, welcome. Other question? Okay. Now, I added also for you a problem on Richardson extrapolation. Okay, for this technique, you should always know that you should start from the expression of your error. And as I told you, don't have to memorize the error. I will give it for you. I give you the expression of the error and you do the derivation. And if, for example, here, when they ask for the trapezoidal rule, okay, we know that if for the trapezoidal rule, it's proportional to h squared. And I will give you the errors expression, and you don't have to memorize anything. The error expression will be given for you, okay? So let's say we are using the trapezoidal method. We know that the error is proportional to h squared, okay? And we want to derive, here they are asking to derive the expression of Richardson extrapolation and to continue to compute values until a stopping criterion of 0.5%. Okay, so what we will do here, we can start, let's say, with considering a variable number of segments, 1, 2, 4, 8, to be able to do the Richardson extrapolation. But they asked before doing this to do the derivation. Okay, so if you want to derive the expression of the consecutive Richardson extrapolation, to start with, Okay, when we do it the first time, you know that the single trapezoidal method, the error for this method is proportional to h squared. Okay, this is why if we can compute first the integral, will derive together why it's 4/3 I2 minus 1/3 I1. Because I asked for derivation, you should go to the basics. Okay, so I will go to the initial form, okay, which is the following one. If I have two consecutive integral, one, and I have, let's say, first I have let's say one segment, okay. Then I have a computation using two segments. Then I have a computation using four segments, example, okay? And I want to do the Richardson extrapolation. Now we know that for the composite trapezoidal rule, when we double the number of segments first, what will happen? We know that if we go back to the expression of the error, okay? Let us go to the expression of the error for the trapezoidal method. So if you go back to the slides, let me open the slides. Sorry, 1 second. So if I want to ask you such thing in the exam, I will give you first the expression of the error, okay? So as I told you, don't have to memorize them. And if we go, for example, okay, if I give you this, you have, this is for the single method. If you have the composite trapezoidal method, this is the expression of the error. So I tell you for the composite trapezoidal rule, the error is of the following form. Okay. Now, how can you use this information? So first, you have already, you know already that the error is proportional to f second. So you can consider from here, you can deduce that you have a, if you want, linear, when you have a linear case, you have an exact integral. And when you have second degree, third degree, fourth degree, you will have an error because the error is proportional to f second. So when f second is different than 0, which is the case for nonlinear functions and of course non-constant functions, then we have an error. And this error is proportional to f second. And we have that the error also is proportional to the length of the segment to the power q. Okay, and we have b times b minus a cube. And we know in this case that whenever we have a composite case, we are dividing, if you want, the initial segment into several ones. So it depends also on the number of segments we are considering. And if they tell you we are using the single trapezoidal rule, then this will be the expression of the error. Okay. Now we can see here that the error is always, if you want, will always decrease with the length of the segment. Okay. So now if we go back to the if we go back to the expression here, okay, we have that the error is proportional to h. Do you hear me? Do you hear me?